Hi, everybody, and welcome to the second part of the practical neurophysiology. Uh, Building on what we covered last time, you remember that we were evaluating the physiological function of the central nervous system. And I told you that when we want to evaluate and visualize the function of the nervous system, a different part of the nervous system should be covered. I told you that we have some higher function of the brain that are being assessed by the mental status. And on the other hand, we have cranial nerve. I told you about 12 pair of cranial nerve and different ways that we have to evaluate the function of this cranial nerve. Some of them were purely sensitive, sensory system, some were pure motor, and some were mixed. Now I'm going to continue the discussion with the sensory function. As you remember, I told you that we have sensory function in all parts of the body. For the cranial nerve, I told you about the evaluation of the trigeminal nerve, and you remember that we provide some sensory maneuver in the face and ask the patient to tell us about the different properties of the sensory information, such as the type of modality, the localization, the texture, the detection of the movement, and so on. And as I mentioned earlier, this evaluation of sensory function should be done in the trunk and in other part of the body. Therefore, we say we have to evaluate the sensory somatic sensory function. How we evaluate the sensory function in the body? As you can see here, uh, we uh, we evaluate the sensory function in different
Close his eyes
in
as you
different part of the body using the some maneuvers. For example, as you see in this figure, in this film, we ask the patient to close the eye and touch different part of the body. And while we are touching different part of the body, we ask the patient to tell us what they feel, if they are the same in two direction, into side or not, localization, texture, movement, timing of the sensation. One sensory function that we are frequently use to evaluate the sensory function, particularly the sensory function that sensory receptor that have very high adaptive speed, is to use a vibration fork or vibration diapason and place it on the finger. We expect that the patient is able to detect this vibration. Please pay attention that your finger is under the patient finger. If I am able to sense the vibration, that I'm a little far again from the diapason, if I am able to sense this vibration, then the patient should be able. Therefore, we use this test to evaluate the sensory function in this part, in different part of the body. And you know that there are several other maneuvers, but there are the same. Just we want to evaluate if they are the same, if they are the same in two side, if the patient is open. And you know that those who have problem in the sensory function show some irregularity in one part of the body. For example, in one finger, I do not have a sense of vibration. I have a crude sensation. I can sense something on my finger, but I'm not able to localize it, or I'm not able to detect the texture. This shows that the function of the sensory nerve or pathway or cortex is being impaired. Have a look at this uh, evaluation in this film. As you see, the vibration is being checked.
test to check the reliability of the patient is to strike the tuning fork like this, but then to dampen it by keeping it against your hand, stopping the oscillation, and then attempting to do the test again. And this way you will be able to test the reliability of the patient's response. We'll do this also in the lower extremities. Close your eyes, please. And now, feel that?
Yep.
And do you feel that?
Yeah.
Does that feel similar or dissimilar?
Similar.
Okay, you can open your eyes. The final test for sensory function is to test sharp and dullness with a safety pin. Always dispose of the pin after you've used it to avoid transmission of the hepatitis and AIDS viruses. So I'm just going to open this pin, Mr. Johnson. I'd like you to close your eyes for me. And this is dull, and this is sharp. Okay? What's this?
Dull.
Okay. What's this?
Sharp.
Okay. What's this?
Sharp. Dull.
Okay. Keep your eyes closed. What's this?
Sharp. Dull.
And what's that?
Dull.
And what's this?
Sharp.
Okay. Keep your eyes closed. This is sharp. And this is dull.
Okay.
Okay. What's this?
Dull. Sharp.
Okay. And this is sharp. And this is dull. What's this?
Dull.
Okay. And this.
Dull.
And this.
Sharp.
Okay. Does it feel about the same?
Yep.
Okay.
After evaluating the sensory function in different parts of the body, particularly upper extremities and lower extremities, trunk, and you get sure that everything is okay, then you should check the motor function of the body. Somatic motor function. I mean that movement that we are doing in our trunk, in our hands, and legs, and if they are the same in two sides or not. We do not evaluate the strength of a patient and compare it with another patient. Just evaluate it and compare two sides of the same patient together. Have a look at this film, and you can see what I mean. That when we are assessing the motor function, how we evaluate the strength and symmetrical movement that we expect a patient is able to do.
Bring your chin down. Trap my hand. Bring your chin down and press and relax. And do it back here. Press and relax. Trap my hand over here and relax. Trap here and relax. Push forward and relax. Push back and relax. You bring your arms up like this and push and relax and push down and relax. Make a fist for me. Don't let me open them. And relax. And don't let me push your wrists in.
As you can see in this film, we are checking the agonist and antagonist muscle. One time we are pushing back and one time pushing forward. In this test, in fact, we are evaluating the antagonist muscle that are working, and if they are normally working, and if they are the same in two direction or not.
And relax. Good. You can put your arms down here. We're now going to assess motor function in the lower extremities. Push up and relax and push down and relax. Push forward, relax, push back, relax, push up, relax, and push down and relax.
When we did this test, then we are able to have a judgment if the motor function, somatic motor function, is normal or not. You know that after a stroke and after different injuries to the nervous system, particularly the motor cortex or motor pathways, we have irregularity in this movement. For example, one patient is not able to move one hand or one leg, or sometimes the movement are weaker in one side in comparison to the another side. This shows that motor function is impaired. Then we should evaluate for what is the reason. But physiologically, we are talking about at the physiological level. Physiologically, as you saw in this figure, in this film, we expect that two sides are the same. Now, if you remember, I show you a map and I told you we evaluate the cranial nerve, somatic motor function, somatic sensory function, and one another function was the cerebellar function. This is showing the agonist and antagonist muscle that I told you, and when we are doing these experiments, we are checking the motor function of this muscle in the antagonist muscles. Now we are going to evaluate the cerebellar function. For cerebellar function, we have different type of tests. You know that cerebellum is involved in different functions. Originally, cerebellar is involved in the balance, maintenance of the balance. The cerebellum is involved in the learning of motor movements and motor memory, timing of the movement, the correction of the movement according to the feedback that it received. Therefore, there are several tests that I bring some of them for you. I am not going to provide all of them, but just bring some of them for you. One of these tests is finger to nose, as you can see in this figure, in this film. In the finger or nose,
One test for cerebellar function is
in the finger to nose test, we are evaluating the timing of the timing function of the cerebellum to evaluate if the motor cerebellum is able to help the patient to learn the localization of the target and control the movement according to the information that it received from the joints and the angle of the joints. And we do the test like this. Listen.
the finger to nose test. I'm going to place my finger here, and if you raise your right finger and touch my finger and touch your nose. Touch my finger, touch your nose. Touch my finger, touch your nose, close your eyes, touch my finger, touch your nose, touch my finger, touch your nose.
As you saw, even when the eye is closed, this patient is able to detect where is the finger placed according to the information that it received from the joints and the localization that it can produce. It is able to, this patient is able to detect, and as you see, with very small error, it reached the target even when the eye is closed. Those who have problem in the cerebellum show dysmetria and pass point. I mean that the finger is passing the point, is not able to find the target even when the eye is open. Have a look. Excuse me.
And you can open your eyes. An important assessment of cerebellar function is the Romberg test. Would you put your feet together for me? And just bring your arms up like this.
Excuse me.
Together for me.
The next test that we are using for evaluation of cerebellar function is Romberg test. As you know, I told you that cerebellum receives the information from different joints and the pressure that we sense in our soul. Therefore, According to this information, it maintains the balance with the cooperation that it has with this vestibular system. Therefore, we believe that those who have problem in the cerebellum, they just rely on the visual information to maintain their balance. I mean that when they are moving, the movement of the object toward the face will be detected by the eyes, not by the cerebellum. Therefore, in the Rumberg test, we ask the patient to stand and close the eye. If they are able to maintain the balance even when the eye is closed, and those who have normal cerebellum function maintain the balance easily. Have a look.
And just bring your arms up like this and close your eyes, and I'm going to let your hands go. And just stand like this with your fingers open. Fine. You can open your eyes, put your arms down. We're now going to assess gait.
As you saw, there was no imbalance or no disruption in the balance. Therefore, it showed that cerebellum received the information not just from eye, from the joints and from the pressure receptor, and therefore this patient did not show any imbalance. Another test that is being used for the function of cerebellum is gating. You know that gating is a very complex movement that need the coordination of the time and coordination of the muscle that should be active and then deactive, agonist muscle, antagonist muscle. And for this reason, if we have a patient that have a cerebellar function, this patient is not able to produce a normal gating function. And when we want to check the cerebellar function, just we ask the patient to do different type of gating, different type of walking, and then we check the movement regularity of the steps, if the steps are being done with a normal balance, and have a look at this film.
The final part of the neurologic examination is assessment of gait. Would you walk toward me and stop right there and turn around and walk on your toes? And turn around and walk on your heels to me. And stop right there and turn around one foot in front of the other. Tandem walking, like you're walking a straight line. Fine. And you can stop right there. And this concludes the...
This was showing that this patient was able to do the gating very normally. But you may ask me, if the cerebellum function was not normal, how was the gating? The gating would be ataxic gating. Ataxic gating, and I will show you something. Let me show you some irregular finger to nose test. This is a normal finger to nose test. And this is abnormal in the other side of the same patient. As you see, the pass point, the patient is not able to find the target easily. It shows the pass point, and even the patient is not able to find the tip of nose, and this is showing a problem in the other side of the body, in the spinocerebellar pathway, and this is very abnormal type of the finger to nose. Okay, what about the ataxic movement, ataxic gating that I told you we have in the cerebellar dysfunction? Have a look at this type of gating. In coordination of the steps, as you see, in poor balance, all of them is because of the problem in the cerebellum that produce ataxic gating. A similar type of
At first, marooners are very
ataxic gating is seen in the alcoholic intoxication. Those who are drunk do not show a normal balance, and this is transient, but it is very similar to ataxic movement. We have in the even in the animals, the ataxic gating could be seen when they are using or eating fruits that are fermentized and have high level of alcohol. Have a look at this. There are some fruit that remain on the trees for a long time and have high level of alcohol, and animals start to eat them. And when they eat these fruits, this produce a level of incoordination of movement like ataxic movement that I told you. Have a look. All animals are eating these high alcoholic fruits, and then what is the result? This is the result. As you see, there is no normal gating. I'm not going to compare it with human, but I'm just saying that a very similar type of ataxic gating is seen in these animals. Okay, let's go forward with the last part of the neurological examination. Physiological neurological examination. You know that in each part of this evaluation, if we saw any type of irregularity, we are able to check it with very sensitive and sensitive methods, and more sensitive method. But at this level, this is the physiological level. The final part of neurological examination is spinal reflexes. You know that for several type of reflexes, a spinal cord is the center of reflex. I mean that if we cut the spinal cord and disconnect it from the brain, these reflexes remain. Therefore, they are named as spinal reflexes. We have several type of spinal reflex in the upper limbs and some in the lower limb, according to the localization of the receptor. As you recall from the last discussion that I told you about the reflex arc. You remember I told you that we have a reflex arc, and one of the elements in the reflex arc was receptor. For the spinal reflex, according to the type or to the localization of the receptors, we can classify a spinal reflex into two parts: superficial spinal reflexes, that the receptor are placed in the skin, and the deep spinal reflexes. Let me to bring you some example of the superficial reflexes. For example, abdominal reflex. In the abdominal reflex, if a light stroke of the abdominal wall lead to the contraction of underlying abdominal muscle, and immediately in this way the muscle will be contracted. This is superficial spinal reflex. Or another superficial spinal reflex that can be seen can be evoked in the boys is cremasteric reflex. If you stroke the inner surface of the leg, immediately the testis will be contracted and move upward. This is a cremasteric reflex. Or another superficial spinal reflex is flexion withdrawal reflex. When we put our hand or leg or our foot on a sharp object, immediately we withdraw from this sharp object. And this is a reflex that is not being done deliberately. It is completely involuntary. Another superficial reflex is plantar reflex. And in the plantar reflex, we stroke the lateral border of the sole, and immediately the toes will be contracted and flexed toward the sole. This is a superficial reflex. Therefore, if I ask you about the type of reflex, which of these reflex is superficial, you should know which are superficial. For the plantar reflex that I told you, we stroke this part of the sole. We expect that all toes should be contracted together, but there is a pathological sign named as Babinski positive sign, that fingers are being opened like this, and you see that toes are separating from each other. This is a Babinski positive sign that is pathological, unless in the infants, that we know in the infants, because the pathway is not completed yet, this sign is normal, but in the adult it is not normal. The second part of the spinal cord reflex is deep spinal reflexes, and you know in the deep spinal reflex we try to stimulate the muscle spindle that is placed in the deep area of the muscle. We use a reflex hammer, and we use this reflex hammer like this, that the hand is fixed, and the wrist is moving, and the hammer tip will hit the muscle tendon and it should be sudden. When we suddenly stretch the muscle tendon, the muscle will be stretched. And what will happen next? When the muscle is stretched, immediately a spindle will be stimulated. And then when the muscle is stimulated, stretched, and a spindle will be are stimulated, they start and initiate a contraction of the whole muscle, and therefore we have a movement in the limb. We have some tendon reflexes in the upper limbs, such as biceps reflex and triceps reflex. What is biceps reflex? For doing the biceps reflex, we put the hand on one supportive area, such as the leg, or place the hand in our own hand, and place our toes, our finger in the on the tendon of the biceps muscle, and hit our own thumb. When we hit our thumb, the biceps will be stretched, and immediately it shows a contraction, and flexion of the arm will be seen. I'm ready. When you are in university, and you are free, you can set the time to me with me, that and we can do this test in the lab and exercise it, because in the lab we have hammer, and we can review them. But let me show you in this figure, in this reflex on a film. Another reflex is a triceps reflex, or triceps tendon jerk. In this time, we have a support for the hand. The hand weight is on our hand, and suddenly with hammer we strike the triceps tendon that about 5 centimeter above the olecranon process, and the result will be a contraction that you can see in by this arrow, contraction of the triceps muscle and extension of the forearm. Another reflex is brachioradialis reflex. This is again a reflex that is elicited in the upper limb, and as you see, we strike the radius about 5 centimeters above the wrist, and the supination of the hand would be seen. Have a look at this.
You can get it in other ways. We recommend this. I'm going to begin with the brachioradialis reflex.
Brachioradialis.
Tap on the tendon.
Have a look at this, the fingers.
And this
movement.
is a C5-6 reflex. I'm
This
also
is
going to do the
brachioradialis.
biceps reflex by putting my hand on the biceps tendon, and then I'm going to strike my thumb, and I will feel the contraction as well as perhaps see the muscle contract. I think one important caveat is that it's important to keep your eye glued on the muscle and not so much focused on the movement, because if it's a very depressed reflex, all you might see is a contraction of the muscle. That level is C5, 6.
As this guy this guy explained, we should have a look at the muscle, because the muscle contraction is not very strong. We should not focus on the hand movement, arm movement. We should focus on the muscle contraction, and if we also feel by our thumb, we feel the contraction of the biceps muscle. You saw the contraction that happened in the biceps and the arm, and now the triceps reflex.
Again, for the biceps, I'll now do the triceps, which you could do many ways. If he's relaxed this way, I could just choose to leave his arm in the position it is, and I'm actually getting a good reflex in this fashion, so I probably wouldn't proceed further. But I could also suspend the arm like this, instruct the patient to lean on my hand as though leaning on a railing, and the measure of the hand being relaxed is that the forearm is loose, and then once again strike the triceps tendon, and this is a 6-7.
As you saw, the first response was not very clear, but the second one was completely clear, and you saw that hand show a movement like this.
And this is a 6-7.
But what about the tendon muscle in the tendon muscle reflex in the lower limbs? The most famous one of the reflex is the knee jerk. That in the knee jerk we stimulate or stretch the tendon, and the knee show a very strong movement. For doing this knee jerk or patellar reflex, we should strike the patellar tendon just below the patella. Before, the patient should be placed and sit down in a comfortable way, that the leg is completely relaxed. And when we strike the patellar tendon, the contraction of quadriceps femoris muscle will show a extension in the leg. And another reflex is the ankle or Achilles reflex. And this time we hit the Achilles tendon here, and we put the toes with our hand and sense the patellar flexion by our hand. Have a look at this figure and at this film.
The patellar reflex is evaluated by placing your hand on the person's thigh, and close your eyes, please, Mr. Johnson, and striking the tendon briskly. One more time. We would repeat this on the other side as well. We're now going to do the Achilles reflex.
Achilles reflex.
One method of assessing the Achilles reflex is to flex the hip, knee, and ankle, as I'm doing now, and to briskly strike the Achilles tendon. The response we're looking for is plantar flexion of the foot. While we're in this area, we can also attempt to elicit a Babinski reflex. Remember that a Babinski reflex is an abnormal reflex. We place the tip of an applicator stick at the heel of the foot and bring it on the lateral margin, coming to the base of the toes, running to the base of the large toe, as shown. The normal response is plantar flexion. The abnormal response is dorsiflexion and a fanning of the toes. This response, an abnormal reflex, is seen in pyramidal tract diseases. And this concludes our assessment of reflexes. We're now going to continue with the assessment of motor function.
Okay. By these reflexes that I told you, the class comes to the end, and I can say that by these two sessions that I had with you, we evaluate the different part of the nervous system, not just one part of the nervous system, all part together. The central nervous system is not zero, one system. We cannot say that if the sensory system is normal, therefore everything will be normal. it is not true. We should check all the item together, and I bring you different type of very simple experiments to evaluate the normal function of the nervous system in different parts. I'm not going to say that everything was covered in these two lectures, but this was the physiological level. Every time and everywhere that we see an abnormal response, for example, in the hearing sensation, then we can refer the patient to audiometric assessment to evaluate it in more detail. Or it may need some, for example, imaging tests, or some other precise tests to evaluate the abnormality. But at the normal level, when we are talking about normal physiological function, we believe that this is enough and is enabling us to have a judgment about the normal function of the nervous system. If you understand the normal physiological function of the nervous system and the theoretical concept behind them, now by doing these experiments, I'm sure that you understand all the nervous system and the function of the nervous system clearly. I hope that these two sessions was helpful for you and informative enough for you. Again, I'm ready to bring the possibility and opportunity to do these tests when you are in the university, and then exercise with yourself. But most of these experiments are easy to do even in the home, because it do not need any instrument and is easy to do. Thank you very much for hearing me, and I hope that this film was informative enough. Have a good time and goodbye.